Welcome back, everybody. We are going to be looking at the last lesson in Unit 9, which is on using quadrilaterals or classifying them and utilizing their properties when they're all put together. So let's go ahead and go to our notebook and we'll get started. So in the last lesson, I gave you this chart. We are definitely going to be using this chart as well as all of the properties, which we did not finish actually, our property list in 9-6. So let's start with that. So trapezoids, all four sides are not congruent, opposite sides are not congruent. Diagonals bisect each other, that's not true. Each diagonal bisects a pair of opposite angles. That's not true. That's true in kites and rhombi though. They are exactly one pair of opposite angles that are congruent. That happens in kites. Opposite sides are parallel. That's not true in either of those. Diagonals are congruent. That does happen in isosceles trapezoids only. Consecutive angles are supplementary. That is true in trapezoids that are isosceles only. Diagonals are perpendicular. That happens in kites. Opposite angles are congruent. That doesn't happen in either. The diagonal that sets the opposite congruent angles is bisected by the other diagonal. That happens in kites. And all four angles are right angles. So that's not true. So we finished that up. Hopefully that will help you with this lesson, which is lesson 9-7. And it is on using and classifying quadrilaterals. Okay, and this entire lesson basically just revolves around our questions here. So it's just basically going to be taking what we know already and putting it all together and applying it to classifying quadrilaterals. So the first one says quadrilateral ABCD has at least one pair of opposite angles congruent. What type of quadrilaterals, not triangles, meet this condition? So the really cool thing is we can go back to our chart. So one pair of opposite angles congruent. So if we go back to our chart back here, one pair of opposite angles that are congruent only happens in kites. So we know that this has to be a kite. What is the most specific name for a quadrilateral ABCD? So we know that these bisect each other. We know these bisect each other, but because all four of these are not exactly the same, we know that it's not a square. We know that it's not a rhombus. So we don't know anything about the angles, even though they appear to be right. We don't know that. So therefore, the most specific name that we can give this is a parallelogram. The next question says, is there enough information to show that quadrilateral PQRS is isosceles? In this case, yes, there is. And the reason is because if these two are congruent, these two automatically have to be congruent because these two are consecutive. So this has to be 106 degrees. And so therefore, yes. And the reason why is that isosceles trapezoids have consecutive interior angles that are supplementary. Okay, quadrilateral DEFC has at least one pair of opposite sides congruent. What types of quadrilaterals meet this criteria? So at least one pair. Oh, this one up here says at least one pair of opposite angles congruent. So parallelograms have at least, they have more than one. And rectangles have at least one pair of opposite angles. And squares do too. And rhombi do as well. So everything that we've looked at. Okay, so quadrilateral DEFC has at least one pair of opposite sides congruent. What triangles, type of quadrilaterals meet this criteria? So at least one pair, which means it can have more than one pair of opposite sides congruent. So that would be a parallelogram. That would be a rectangle has at least one, has two. That would be a square, it has two. That would be a rhombus, it has two. It would be a trapezoid, but specifically an isosceles trapezoid, because a regular trapezoid doesn't have to have any congruent sides. And a kite also has at least one pair of opposite sides congruent. So the next one says, give the most specific name for each quadrilateral, explain the property or properties you are using. So this one looks like this is congruent to this, and this is congruent to this, which would make this a kite. And the property, if we go to our theorem handbook pages, so that we can get the correct name, would be I think it's just definition. Yes, that would be definition. Yeah, this is just by definition of a kite. And this guy over here has one pair of opposite congruent sides, and it has one diagonal that is bisected, and it has one side that is 9. So if we know that we have one set of opposite sides, that would only be defined by a trapezoid, but that doesn't work because trapezoids don't bisect their diagonals. We don't know that this side is a 9, but we do know that the diagonals are bisected. So if we go back through, theorems, I think that only gives us a parallelogram. And the reason I say that is because we don't know this is 9, but we know that this is bisected, and a parallelogram is the most specific thing we can call it there. The diagonals are bisected, which yeah. I don't know that we can classify this at all, because we don't know that this one is bisected. So I'm going to put on here we can't prove triangles congruent. We can't prove that this side is 9 because we can't prove any triangles congruent for CPCTC. We don't know anything about the angle measurements. I'm not convinced that you can prove this. So this would just be a quadrilateral because I don't think that you can even prove that it's a parallelogram. We would have to know that GF is congruent to DH for us to be able to prove that it's a parallelogram. So I'm pretty sure quadrilateral is the most specific one there. If you think differently, please feel free to come to me and give me an argument. I would love to have someone tell me that I'm wrong there. So that is all it is to it, just basically taking what you know and applying it to quadrilaterals. So if you have any other questions, let me know. If you can figure out the answer to that last one and you think it's different than what I have, please come and explain it to me because I would love to have a debate about whether or not that actually is something more specific. So until next time, we'll talk to you later.